Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. We're solving a common architectural challenge, evolving a single instance application to meet enterprise requirements of high availability and low latency. The key requirements are clear: high availability, no single points of failure, and low latency, fast response times for end users. These two requirements will drive our technology choices. Each option combines three components: instance groups for HA, different load balancer types, and either CDN or Cloud Armor. Let's analyze which combination best meets both requirements. Understanding the requirements. Let's break down what high availability and low latency really mean in practical terms. High availability means if one instance fails, users don't notice. We need multiple instances across zones, health checks, and automatic failover. A single GCE instance has an SLA of 99.5%, that's 3.6 hours of downtime per month. Low latency means fast response times globally. This involves caching static content close to users, efficient load balancing, and minimizing round trips. Every millisecond counts for user experience. The solution must address both requirements equally. High availability without performance, or speed without reliability. Both fail to meet the business needs. Option 1. Network LB plus Cloud CDN. This option combines a network load balancer with Cloud CDN. Let's examine if this makes sense. Here's the critical issue. Cloud CDN only works with HTTP/S load balancers, not network load balancers. This is a fundamental incompatibility in Google Cloud. Network load balancers operate at layer 4, TCP, UDP, and simply forward packets. They have no understanding of HTTP, so they can't integrate with CDN services which need HTTP headers and caching logic. Even if this combination were possible, Network LB lacks global load balancing capabilities, limiting our ability to achieve truly low latency for global users. This option is technically invalid. Option 2. SSL Proxy LB plus Cloud CDN. SSL Proxy Load Balancer with Cloud CDN, another problematic combination. Let's see why. Like network load balancers, SSL Proxy Load Balancers don't support Cloud CDN integration. Cloud CDN requires HTTP/S load balancers because it needs to understand HTTP semantics for caching. SSL Proxy LB is designed for non-HTTP SSL traffic, like SSL-based databases or custom protocols. It terminates SSL but doesn't understand HTTP headers, cache controls, or content types that CDN requires. While SSL Proxy LB does provide global load balancing, good for latency, the lack of CDN support means we can't cache content close to users, a major limitation for achieving low latency. This combination doesn't work. Option 3. HTTP/S LB plus Cloud Armor. This option uses HTTP/S load balancer with Cloud Armor instead of CDN. Let's evaluate this choice. HTTP/S load balancer is excellent. It provides global load balancing, SSL termination, and integration with many GCP services. It definitely helps with high availability. But Cloud Armor? That's a web application firewall, WAF, for DDoS protection and security rules. While security is important, Cloud Armor does nothing for low latency. In fact, it might add slight latency due to security rule processing. Without Cloud CDN, all requests must go back to your origin servers. There's no caching at edge locations. This fails to meet the low latency requirement, especially for global users. Security is good, but it's not what we need here. Option 4. HTTP/S LB plus Cloud CDN. Finally, HTTP/S load balancer with Cloud CDN. This is the combination we've been looking for. HTTPS load balancer provides everything needed for high availability: global load balancing, health checks, automatic failover, and multi-region support. It can distribute traffic across instances in multiple zones and regions. Cloud CDN perfectly addresses low latency by caching content at Google's edge locations worldwide. Static assets, images, CSS, and JavaScript are served from locations close to users, dramatically reducing latency. This combination is not only technically valid but optimally addresses both requirements. It's the architecture Google recommends for global, high-performance web applications. This is our answer. Deep dive. Why HTTPS LB plus CDN works. Let me show you exactly why this combination is so effective for both requirements. For high availability, the HTTPS LB continuously monitors instance health, automatically removes unhealthy instances, and can balance across regions. With instances in multiple zones, you achieve 99.95% plus availability. For low latency, Cloud CDN caches content at 100 plus edge locations globally. A user in Tokyo gets content from Tokyo, not your US servers. Cache hit ratios of 85% plus are common, meaning most requests never reach your origin. The synergy is powerful. The load balancer handles dynamic content and failover, while CDN handles static content delivery. Together, they create a resilient, fast global application architecture. Component compatibility matrix. This compatibility matrix is crucial to understanding why some options don't work. Google Cloud services aren't all compatible with each other. Cloud CDN specifically requires HTTPS load balancer because it needs to understand HTTP semantics, URLs, headers, cache control directives, and content types. Layer 4 load balancers simply forward packets without this understanding. Similarly, CloudArmor only works with HTTPS load balancer because it needs to inspect HTTP requests to apply security rules. It's examining URLs, headers, and payloads, impossible at Layer 4. Always check service compatibility when designing architectures. Just because two services exist doesn't mean they work together. Implementation best practices. Let me share the implementation approach for the winning architecture. These commands and configurations represent production best practices. Start with a managed instance group spread across at least 3 zones. This provides resilience against zone failures. Configure health checks carefully. They determine how quickly unhealthy instances are replaced. When setting up Cloud CDN, pay attention to cache keys and TTLs. Not everything should be cached forever. Use cache control headers in your application to fine-tune caching behavior. Monitor cache hit ratios and adjust your caching strategy accordingly. A good cache hit ratio, greater than 80%, dramatically reduces both latency and origin server load. This creates a virtuous cycle of better performance and lower costs. Summary and key takeaways. The correct answer is option 4. HTTPS load balancer with Cloud CDN. It's the only option that properly addresses both high availability and low latency requirements. Remember, instance groups provide high availability through redundancy. HTTPS load balancer enables global load distribution and health checking. Cloud CDN delivers low latency through edge caching. Together, they create a robust, performant architecture. Key lesson: always verify service compatibility. Not all GCP services work together. Cloud CDN and CloudArmor both require HTTPS load balancer, not Layer 4 load balancers. When evolving single-instance applications, think holistically about availability, performance, and how components work together. The right architecture makes all the difference. Thank you for your attendance. Please consider subscribing to the channel. Thank you.